All right, thank you very much. So, what will you learn in this talk? Here today, you will learn how Jupyter AI provides a general interface for language models. You'll learn how Jupyter AI lets you collaborate with peers and an AI simultaneously in JupyterLab. You'll learn how Jupyter AI lets you ask questions about local files. And finally, you'll learn how Jupyter AI can help provide code insights and help debug failing code. So, to kick us off, what is Jupyter AI? Well, Jupyter AI is an official project that brings generative AI to Jupyter. It's part of the JupyterLab subproject on GitHub. And Jupyter AI provides users with interfaces for interaction and experimentation with multiple large language models. And it's important to note here from the outset that Jupyter AI itself is not a language model. It is instead a human AI interface for multiple language models. So, first of all, why Jupyter AI? Why another AI IDE integration? Well, to answer this question, we need to discuss the big ideas that surrounded the inception and development of Jupyter AI. So, the first principle is that Jupyter AI needs to be vendor agnostic. Jupyter AI should not discriminate between between different model providers. So, for example, Jupyter AI should not lock you into using a particular language model. It should allow users to select and choose freely between multiple language models. And this is in stark contrast to many existing AI IDE integrations that essentially lock you into ChatGPT, which I find to be a little short-sighted. You know, the assumption here is that no language model is ever going to be better than ChatGPT, and I think within the next year or so, we'll see that to be proven wrong. Next principle is that Jupyter AI needs to be transparent and traceable. So Jupyter AI needs to be transparent in the sense that users should always be able to see the final prompt being sent to the language model and always be able to see the output. And it also needs to be traceable in the sense that these are captured in server logs and persisted somewhere. Jupyter AI also needs to be collaborative. So the latest release of JupyterLab 3 and JupyterLab 4 all support real-time collaboration, and Jupyter AI needs to be built with this in mind. Jupyter AI also needs to be exclusively user-driven, and this has major implications in both AI safety and financial billing, right? We don't want to execute a language model without the user's explicit input at any given time. And finally, Jupyter AI also needs to be human-centered. So Jupyter AI should not lock users into any artificial modalities of interaction, but instead remain intuitive and human-centered. All of its interfaces need to be intuitive and easily comprehensible. And with that, I would like to give up the floor to Piyush, who will discuss the two major features of Jupyter AI, which are the Jupyter AI Magics and the Jupyter AI chat panel. Thank you.
Hello, everyone. So what are magics? Magics are these special commands that you can execute code when you're running them in an IPython context. And I have listed, there are two types of magics here. One is line magic with a single %, and then command name, and then the inputs on the same line. And then you have cell magics with a double % command name, and then inputs on a new line. And it shows an example here. It's using the history line magic, and it shows all the previous commands that have been run in that cell or notebook. And why do we need magics in Jupyter AI? So users usually want to experiment with different models and providers. They want to compare them. But the problem is that there's no unified interface to run those providers and models. For example, each of the providers have their own SDKs. So users need to understand those and use those SDKs separately to evaluate different models. They also end up using playgrounds, to evaluate models, but playgrounds don't let you, produce any reproducible artifacts. You can only do screenshots, so you can take exports of the code that you've run. And Jupyter AI solves these problems by providing a very simple interface that can be used also in an IPython context, and I'll show examples of that. So how do you get started with Jupyter AI? You can just do a pip install Jupyter_AI, and it's using the all modifier here. So this will install the Jupyter AI extension, the Magics commands, and also the SDK dependencies for the providers. You need to provide the API keys for the providers that you want to use. So here I'm using the Anthropic and the AI21, but you can export more keys here. And then you can launch JupyterLab. Once you launch JupyterLab, you can load the Jupyter AI magic commands by using this line magic here, %load_extension, Jupyter_AI, and that should load the magic commands for Jupyter AI. How do you use Jupyter AI magics? So you will use the %AI cell magic here, and you can specify the provider, which is the Anthropic here, colon, and then the model name, and then you can specify your prompt as a new line, and that should call the LLM for the provider that you've specified. So you can see an example here. I'm asking to write a haiku about Jupyter, and it came back with that response here. There's also another command called list that you can use, and which gives a list of all the providers that are available in Jupyter AI and that have been registered. And so you can see the output on the right here, which shows the provider and then the models available. And then these green check marks show if you have specified the key, if you've set that in the environment variable, then you'll see these green check marks. That shows that that particular provider is available for use in the AI magics. So this is an example of a use case that I was talking about before, that users frequently want to compare different models and providers. And there's a very quick and easy way to do that with Jupyter AI. So I have this notebook screenshot on the right here, which is comparing 3 different models from Hugging Face. And we're using the Jupyter shortcuts here, and you can select all cells and run them with Shift return. And this, each of the cells, they will run in parallel, and each of the commands that go to the LLMs, they run in parallel. And so this can be used very quickly to compare the outputs from different models and different providers. And the great thing about this is that this is reproducible, this is shareable. You can send that to different users. Another cool feature that Jupyter AI has that you can specify a specific output formatting for the output from the LLM. So currently we support Markdown, HTML, JSON, text markup, image, and of course text. So here's a screenshot that is showing here. It's using the HTML output and rendering an SVG block. The second one here is using the math output and showing the Schrodinger equation. The third one is using the JSON output here, and it's showing basically output from a JSON file. This is another example. It's using the image format, and it's using the stable diffusion model to generate an image, and directly using the image output to render that. Another great feature that Jupyter AI has is interpolation of values. So you can specify your prompt and then use the brackets to specify the variable that you want to interpolate, and you can see here that it's correctly interpolating the values for the poet here and coming back with the poem in the style of Walt Whitman here. And there's a cool feature in IPython magics. There are these special variables with in and out that you can use that basically store the values of the cells inputs and outputs. And Jupyter AI, you can use Jupyter AI to take those inputs and outputs as context to the LLM, and I'll show an example of that. So on the right, you can see that I have this statement of asserting, two values here, and that assertion is failing. And in this next screenshot, you can see that I have specified to the prompt, this prompt with the separator, that I want to use the input from the cell 2 as context to the LLM prompt. And once you run this with Jupyter AI, you can see that the Jupyter AI was able to explain why the code failed, and it also gave an example of how to correct that code. Jupyter AI also provides a chat interface, and I'm going to go into that a little bit. So once you install the Jupyter AI extension, you will see a new tab on the left tab bar, which will provide this chat interface. It provides a conversational interface to do a conversational interaction with the LLM. We support both text and markdown output, not just text. There's also another cool feature that lets you select values from the notebook and then use that as a context, as a context in your prompt. So you can use that as an input to the prompt, and you can also replace the selection, if you want to. And I'm going to show that in a minute. So this is an example of that feature. You can see that on the right in the notebook, I have selected some code in the cell. And then as soon as you select something, you can see on the left on the chat panel, there are 2 checkboxes at the bottom. And as soon as you select something, this left checkbox is checked. And what that will do is, when you specify a question in the chat panel and you send that, Jupyter AI will basically use that selection also as a context, and that will send it along with the prompt. And you can see here in the conversation that is in the chat panel that I have my question at the top. It's asking why the plot was not being shown when I run the cell, but it also took the selection that I had and sent that as context to the LLM. Similarly, this second checkbox that is there, replace selection, if you check that, it'll basically replace the selection in the code cell that you have selected with the output from the LLM. Jupyter AI also works in the real-time collaboration mode available in JupyterLab. And so with that feature, more than one users can chat with the AI interface, and they don't have to, and the inputs to the LLM are running in parallel. So for example, 2 users can simultaneously chat with the AI. They don't have to wait for one user to end their chat. And then, basically peers can ask questions simultaneously to the Jupyter AI. And so you can see example here. There are 2 users here. One is anonymous Pandya and anonymous Ersa here. And the first one has asking question about adding elements of a list. And then the second user came in and asked a question in the same context. And so we are using LangChain to run these chains, and we're using memory so that the context is carried from one chat to another. This is some more examples of the chat in collaboration mode. So on the left is the first user asking a question, and on the second side you can see that a user is asking a question in French, and the LLM is responding with that. Another cool feature of Jupyter AI is that we have these special commands that you can specify with / and then the command name. And one of those commands is generate. And what generate does is that you can specify it to generate a notebook about something. And so, for example, you can see on the right here, the screenshot shows that it asks to generate a notebook about matplotlib. And once you specify that, on the back end, it basically runs multiple chains. It will basically decompose into multiple tasks. For example, it will try to create title and description from one task, and then outline sections, and then the code in those sections, and it'll basically have different chains running in parallel to create that. And I'll show an example of how this particular example works in the next screenshot here. So this is, for example, the notebook that it created with that that prompt that was given before. And you can see it has the title, introduction, and then some sections and subsections. And I'll show those subsections as well. So here you can see the subsections. It has the subsection titles and then the code. This is another screenshot of it, that it actually is creating the plots that actually work. This was another example. Wanted to show that this created a notebook which was a little different than the earlier one. This was for training a neural network with PyTorch. It was able to create a working notebook for this as well. And with that, I'm going to pass it on to David, who will talk about the retrieval augmented generation.
All right, thank you, Piyush. So, what do I mean by questioning files? Well, the basic analogy here is that you can actually teach a language model about the contents of your file, and I'll explain in detail how this process works later on. For now, all you need to know is that the first step is to select an embedding model, and this can be done through the settings panel on the chat widget. So the settings button is on the top right. You just click that button, select an embedding model, and you're good to go. Then you can index a file tree via /learn. And /learn accepts the relative path of a directory. So in this case, I am doing /learn docs, which just so happens to contain all of the Jupyter AI documentation. So as you might imagine, we can do some pretty interesting things with this. And if I prefix a prompt with the /ask command, I can then ask questions about previously indexed files. So here I'm asking, what is Jupyter AI and how can I install it? And if you have your laptops open right now and you tried this on ChatGPT, I guarantee you that it will fail. And why is that? It's because Jupyter AI was conceived after the training date cutoff for language models. So there's no way for a language model to even know about that. But thankfully, because we taught Jupyter AI about the Jupyter AI documentation, Jupyter AI is able to respond very coherently, and it basically summarizes this entire presentation, which might put me out of a job, but hey, at least it does my job for me. Yeah, so you can see here it even explains the magics, the chat UI, all the models are available. Yeah, this is actually pretty cool. Yeah. So another use case, which gets a little bit meta, is that we can actually use Jupyter AI to debug Jupyter AI. I know, just mind blown, right? So here, I'm asking, hey, also, this just for context, this is a pretty common question we get from users, which is, I'm getting an unauthenticated exception when I'm running this cell in my notebook. What authentication should I provide when using an OpenAI model? And here you can see that the user selected the cell that uses a Jupyter AI magic. And again, if you try this in ChatGPT today, there's absolutely no way it would be able to generate a coherent response. But here, Jupyter AI is able to answer, wow, you need to specify the OpenAI API key environment variable, which circles back to what Piyush was talking about with regards to authentication when using magics. Very cool. Another use case is to teach new users how to work with JupyterLab and start developing and contributing. So right here, I already have a directory that contains all of the JupyterLab documentation. So this is literally just the docs under the JupyterLab repo. I do /learn, and boom, Jupyter AI has learned all of the documents in that directory. Very impressive. And now I can ask a question, how do I write a JupyterLab extension that adds a widget to the left panel? Which is kind of like, Jupyter AI. Anyways, and Jupyter AI responds basically correctly. I mean, the first step is to use the cookie cutter to template your extension repository, then add a widget, and then bind that widget to the left area via the shell object, and then run JupyterLab extension build and JupyterLab extension install. And on top of that, it even gives me a helpful documentation link at the very bottom. I mean, that's pretty incredible. So, How does this all work? I mean, it seems like a bit of magic because like we're teaching a language model, but about things that aren't in its training data. And the way this works is a process called retrieval augmented generation. And I'll try to break this concept down. And there are three main steps with regards to retrieval augmented generation. You all may have heard this word, this phrase used in different AI contexts, but I will break it down for you. So the first step is to compute an embedding via an embedding model. So what are embedding models? That's another phrase that I'm sure a lot of you have heard, but maybe some of you don't know about it. So embedding models basically take syntax and map it to a high-dimensional vector space that we call an embedding space. And within this vector space, nearby vectors indicate semantic similarity. So a lot of words here. I'll break this down even further. So for example, let's take the three words dog, canine, and go, the Chinese character for dog. And these are all completely different syntactically. They don't share a single character in common with one another. However, they all mean the exact same thing. They all are labels for the idea of a dog, right? So they are different syntactically, but identical semantically, right? So a competent embedding model should take these three tokens and map them to three different vectors that are all very near one another. So next step, semantic search. And this is what's happening when you run the /ask command. So here, we are using a local vector database / approximate nearest neighbor library, if you want to be pedantic, to perform a semantic search on a prompt embedding. So basically, when you do /ask and you have a prompt, we pass that to an embedding model, get the embedding for that, and once we have that embedding for the prompt, well, the problem of search has actually just been reduced to finding all of the nearby vectors to the prompt embedding. So you can find relevant data just from the prompt. So it's kind of analogous to a local search engine, except that it's a lot more powerful. And why is it more powerful? It's because embedding models can be multilingual, as we have shown in the first column right there. So you could index documentation in English and be able to ask questions about it in French. And right now, we're doing this via a library called FAISS, Facebook AI Similarity Search. And so that gives us a list of possibly relevant search results from the index directory, right? So we index, for example, like the previous example, we index the Jupyter AI documentation, and when we perform the semantic search, we compute the embedding for the prompt, find relevant data in previously indexed directories, and we gather a list of search results. Now, the next step is prompt injection, and this also happens under the hood. So basically, we take those search results and just inject them into the top of the prompt. Really, like, nothing too fancy here, right? Like, this is just like string concatenation. We're taking those search results, injecting them to the top of the prompt, and this is what allows the language model to answer questions about data that it wouldn't have known otherwise. It's because we're providing that context in the prompt itself. And right now, we are doing that via LangChain. So to briefly recap, right? First step, compute the embeddings via an embedding model. Then from the prompt, find all the nearest vectors, to the nearest embeddings to that prompt embedding, and that gives us a list of search results. And finally, we take those search results, inject them in the top of the prompt, and all the language model has to do is just reason about it, and generate a coherent response. Whew, all right. Takeaways, what have we learned today? Why am I here? You have learned today that Jupyter AI provides a general interface for multiple language models. You have learned that Jupyter AI lets you collaborate with peers and an AI simultaneously in JupyterLab. And this kind of circles back to that big idea of democratizing access to compute and open science that was mentioned, that was highlighted earlier in yesterday's afternoon talk on governance. This lets users that may speak completely separate languages collaborate with one another. Jupyter AI also lets you ask questions about local files, which, as you might imagine, can be extremely useful for software development. And we're already putting this into practice. We have used Jupyter AI to develop Jupyter AI, at least some components of it. And Jupyter AI can provide code insights and help debug failing code. All right, so what's next, right? I'm not impressed enough. Like, I want to see more. All right, so the future? Well, for one, we would love to see multimodal models in chat. So we're talking text-to-image models like ChatGPT or image-to-image models like the various imitating ones that exist. How we design interfaces to that for those is a very open question that we are actively exploring. It would also be incredible if Jupyter AI could index upstream documentation. So imagine a world where Jupyter AI just reads the dependencies from your pyproject.toml, setup.config, etc., and just goes to PyPI, searches the documentation link, uses a web crawler, scrapes the entire documentation page, and then indexes all of that into the vector database so that you can ask questions about it via /ask. I think that would be pretty damn helpful. And finally, LangChain agents. So basically, agent tools basically allow a language model to actually perform actions. So for example, editing a file system, right? Right now, by default, language models can only do one thing: return you a string, right? But people are doing active research in discovering how language models can actually perform actions. And we are calling these agents. So basically, imagine a world where you can ask Jupyter AI to refactor a file, and you don't have to select it and then move it into the chat. Like, you could just say, "Hey, Jupyter AI, refactor this. I don't like it. Someone else wrote it. I don't like it," right? And how you do this safely is a pretty tricky question that we are working on actively. And there's lots of other things. We are running out of time, so I can't cover all of the things I'd love to see in Jupyter AI. So please check us out on GitHub. Again, I wasn't lying. We are under the JupyterLab sub-project on GitHub, so you can go verify that independently. And we also have documentation live and upstream on Read the Docs. Somebody already took the Jupyter.ai domain name, sadly, but we'll work on buying that. Huge thank you to our team at AWS, Brian Granger. You might have heard of him. He's a co-founder of Project Jupyter. He is actually our manager. Go follow him on Twitter. And Jason Weil and Andrei Eroshenko, they're both our coworkers. They have contributed enormously to Jupyter AI as well. Sadly, could not be here for the conference, but they have played a substantial role in developing this and getting it off the ground. All right, huge thank you to everybody who attended this talk. My name is David Q. This is Piyush Jain. Yeah, thank you all very much. I don't believe we have time for Q&A, unfortunately, but we will be outside the AWS booth upstairs until 12:30, unless there are no remaining questions. And feel free to message us on Slack if you'd like to chat about Jupyter AI. Thank you very much.